So my previous video on this just didn't cover the audio for whatever reason. So I'm going to very quickly just kind of go over this. So we're given these three cases where you have an object moving to the right and accelerating to the right, an object moving to the right with constant velocity, and an object moving to the right but accelerating left via tension rope. And the question being, which force is going to be bigger than the other? And the way we do this is we think about Newton's second law. Force equals mass times acceleration, particularly the fact that it's the net force. So if we look at this first example, we see there's a net acceleration to the right. So that tells us that we have to have unbalanced forces. We have to have more force on the right-hand side. And we can denote that in terms of a free body diagram with just a bigger vector. When you're moving at a constant velocity, and this is kind of one of the big ideas in Physics 1, is it's not why an object's moving, it's why an object's motion is changing. This one doesn't have it. It has a constant velocity. So we would make both arrows the same, the friction and the tension. And then for something moving to the right and accelerating to the left, that would tell us that friction is going to be the bigger force here as opposed to the tension force because it's accelerating. We're going to have unbalanced forces to the left. So the real key here, if you want to know which force, how to rank these forces in terms of magnitude, is thinking of acceleration. Another idea is thinking of velocity. If velocity and acceleration point in the same direction, like this or like this, then our object is speeding up. If they point in opposite directions, like this or this slows down. So if you throw a ball in the air, at first it's going to go up, 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 and then down, 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 down. At, say, this point, your velocity vector is going to point up, acceleration vector is going to point down, so that tells you you're going to slow down until you reach here, and then velocity and acceleration point in the same direction, and you speed up till you reach a terminal velocity. So just to summarize really quickly, the trick here is to analyze the acceleration to see where your object is accelerating, and that'll help you determine where you have unbalanced forces.